The first one, figure 1.1, shows the axes used to plot a distance time graph. On a figure, draw a distance and time graph for an object moving at a constant speed and decreasing speed. Use screen annotation to sketch the graph for constant and decreasing speeds. A distance time graph for an object moving at a constant speed. That's right. So it will be a straight line and label that is A. The letter A for a constant speed. And the decreasing speed, if for object speed is decreasing, so if speed is decreasing, the slope will also decrease. So that is B. And on the same graph, we have to, we have to separately plot the two graphs. So first one is a straight, that is A. And the second one, that is B, which shows that the speed is decreasing. The next part, figure shows axes used to plot the speed and time graphs. On a figure, draw graphs for objects which are moving at a constant acceleration, label that is S, and another graph for increasing acceleration, label that is T. So use screen annotation to complete this part. So speed time graph, the slope represent the acceleration. Because acceleration is constant, so it will be a straight line passing through a region. What about the object? Acceleration is increasing. So D, that is correct. The slope increases means the acceleration increases. A plane is at rest on an airport. The brakes of a plane are released and the engine of a plane provide a constant accelerating force. Use the data, calculate the takeoff speed, ignore any effect of resistive force. We have the resultant force, constant force, we have the mass, and we have the time. So first, what we do, we'll use a formula F equals ma. Force is mass multiplied by acceleration. So acceleration is force divided by mass. So 56,000 divided by mass, which is 16,000. This will give us the acceleration of the plane, which is 3.5 meter per second square. And after getting the acceleration, we need the final speed. So acceleration is change in velocity divided by time. The plane starts from rest. So this was 3.5. In final velocity, we don't know. Initial velocity is 0. And the time, it took 16 seconds. So this is 16 divided. Other side will be multiplied. So 3.5 multiplied by 16. We'll get the final speed, approaching speed, which is 56 meter per second. So this is the speed at which the plane will take off. Explain why momentum is a vector quantity, a physical quantity which is having a direction is known as the vector quantity, because it has direction. That's why we say momentum is a vector quantity. The crumple zones at the front of a car are designed to collapse during a collision. So basically, the kinetic energy converted to elastic strain energy when these crumple zones collapse. In a lab test, the car of a mass 1,200 kilogram is driven into a concrete wall. Figure 2.1 shows a video recording of a test shows that the car stopped after 0.36 seconds when it collided with the wall. The speed of the car before the collision is 7.5. Calculate the change in momentum. Change in momentum is a final minus initial. Because finally the car stops, so final momentum will be 0. Initial momentum, the mass of the car is 1,200 and the speed at which the car was approaching the wall, that is 7.5. So 7.5 into 1,200, that will give us about 9,000 kilogram meter per second or Newton second, which is also a unit of impulse. Why initial momentum? The final is 0 because of car brought to rest. So it means the final speed is 0. Then we need the average force. So if we know the impulse is force multiplied by time. So we have the impulse in the previous part, that is 9,000. Force we don't know, and the time interval, that is 0.36 of a second. So it is multiplied, at the other side it will be divided. So we'll get the average force which this car will experience, which is about 25,000 newtons. A different car has a speed of 1,000, has a mass of 1,500. It collides with the same speed. All of the energy transferred during a collision absorbed by the crumple zone. The energy absorbed by the crumple zone is 4.3 exponent 5. Show that the speed of the car before the collision is 24. So basically what happened, the kinetic energy as the car was moving, it was having a kinetic energy. And if we assume there is no loss of energy, so all the kinetic energy converted into elastic strain energy. So we can write the kinetic energy is equals to elastic strain energy, or Ke is equals to elastic strain. Elastic strain energy is 4.3 into 10 to the power 5, and kinetic energy is half mv square, or I can say 0.5 mv square. The mass of the car is 1,500, so 0.5 multiplied by 1,500 multiplied by v square is equals to 4.3 into 10 to the power 5. This is all multiplied, other side will be divided. So v square is equals to 4.3 into 10 to the power 5 divided by 0.5 into 1,500. We need v, so we'll take a root here. This will give us the value of a speed, which is about 24 meter per second. Suggest what would happen if the car is traveling higher than 24. So it will cause greater damage to the car. It will deform more because it will have a higher or initial kinetic energy. Question 3. Stationary object is acted upon a number of the forces. State the condition which must be true for if the object does not accelerate. If the object does not accelerate or object does not rotate. So if it does not accelerate, means there should be no resultant force. Because if there is a resultant force, object will accelerate. If it does not rotate, so there will be no resultant turning effect or no moment. Figure 3.1 shows a boat that has been lifted out of a river. The boat is suspended by 2 ropes, as you can see, and it is stationary. So the weight of the boat acting at the center is 24 kilonewton. The tension in the rope T1 and there is a tension in the rope T1 and T2. The moment or turning effect of the weight about point P. So this about point P, what it shows that P is a pivot. So we want a turning effect about point P. So P is a pivot. So this is a force. And we want the moment of the weight, like turning effect caused by the weight. So moment is a product of force and distance. So force is 24 kilonewton, or we can say 24,000 Newton. Multiply by distance from the pivot. So this distance is 0.4. So 24,000 multiplied by 0.4 will give us the turning effect due to the weight, which is 9,600 Newton meter. Anti-clockwise. So 9,600 Newton meter anti-clockwise. Now we want to calculate a tension T1. So how to calculate a tension T1? Because this boat is suspended, so we'll consider this boat is in equilibrium. So if the weight is causing an anti-clockwise moment, T1 is acting upward, it will cause a clockwise moment. And what about T2? T2 does not cause any moment or a turning effect because T2 is acting on the pivot. So when force is acting on the pivot, the perpendicular distance is 0. So the total clockwise moment is equals to total anti-clockwise moment. So the total clockwise moment, that is T1 multiplied by distance from the pivot, the total distance, that is 1.2 plus 0.4, 1.6. Equal anti-clockwise moment, the force 24,000 Newton multiplied by distance from the pivot, that is 0.4. So if we want T1, it will be 24,000 Newton into 0.4 divided by 1.6. This will give us the value of T1, which is 6,000 Newtons. Then we want to calculate the value for T2. Now the upward forces must be equal to downward force. So if the T1 which is acting upward is 6,000 Newton, T2, the weight which is acting downward is 24,000 Newton. So what should be the value of a T2? The upward force must equal to the downward force as it is in equilibrium or balance. So we can say 6,000 plus T2 is equals to 24,000. Or 6,000 will move other side. So it's 24,000 minus 6,000. That's equal to 18,000 Newton. So to solve this part, we use the clockwise moment equal to anti-clockwise moment. And to solve the tension part, we use that there's no resultant force or upward force equal to the downward force. In question 4, figure 4.1 is a Galilean thermometer. This thermometer used to measure the approximate temperature of surrounding air. The bulb A labeled 20, 22, 24. So a glass cylinder containing water, when the temperature of a water changes, so its density as well changes. And each bulb has a label printed with a thermometer as shown. The bulb have different densities at 21 degree. Only bulb A is at the bottom of the cylinder. Explain in terms of density why bulb A is at the bottom of a cylinder and other bulbs are floating. So why other bulbs are floating and A is at the bottom? Because when the temperature is low, the particles are closer. So the density is high. And that's why A is sink or A is at the bottom. But for other bulbs, the density of a water is low. As the density of a water is low, it will float. So in terms of density, why bulb A is at the bottom? So it shows that the density of the water in A is higher compared to other bulbs. So A will sink. The temperature of a surrounding air increases above 23. Suggests one reason why there is a delay before the temperature of a water increases to 23. So why there, like example, when the temperature is rising like above 23, then what will happen? This bulb B will sink. As a result, because what happened, the density of the water changes as the temperature change. So the density of the surrounding water, this water changes. So as a result, the bulb B will also sink. So why there is a delay? Why instantly it does not happen? Because as the density of the liquid is also changing, glass is not a good conductor of heat energy. Like this is a glass cylinder and then there is the water. So first the glass will take some time to show a change in temperature, like to transfer the heat energy, and then the heat energy transfer to the water and the liquid inside the bulb. So the answer for this part, because the glass is not a good conductor, so it will take time to transfer the heat energy. Explain after this delay the bulb B sink. Assume that the bulb do not expand. So after the delay, when as I mentioned, the temperature of a surrounding air increases 23 or above 23. So when the temperature of the surrounding air is above 23, the heat transfer to the surrounding, the water from surrounding to water, it will become 23. And what we observe the bulb B will also sink. So the reason why the bulb B is sink, because as a result, when the temperature increases, the density of the water will decrease. So as a result, when the density of the water decreases, now the bulb B will have a greater density. That's why it will sink. And bulb A, B, C are now at the bottom. And bulb D and E are floating. State the possible temperature. Look how this is working. I will explain how this Galilean thermometer is working. When the temperature of the surrounding air, example, is 21, higher than the labeled 20 bulb, so bulb which is having a lower temperature, that will sink. When the temperature of the surrounding air is now, example, 23, so which bulb will sink? The bulb B will sink. When the temperature of a surrounding air is like 25, it is higher than all the temperatures, so which bulb will sink? A, B, C, and will sink. So the question is A, B, C are sinking and D and E are floating. So what will be the temperature of the air? So what we can say the temperature of air might be 25. Because once the temperature of the air, surrounding air, is equal to the temperature of the labeled bulb, that bulb will sink. Then the next, state two ways in which evaporation is different from boiling. Evaporation, it is a slow process. Evaporation occur at the surface. Evaporation does not produce bubbles, where boiling produce bubbles. Give one example of a change of state which does not involve boiling or evaporation. So change in state which does not involve boiling or evaporation, so we can say melting. Then the graph in figure 5.1 shows a variation of a temperature of a substance initially liquid. So here, when the temperature is changing, the state does not change. So in the beginning, we'll have liquid. Then here, the liquid freeze, convert into solid, and then we will have a solid. State what is taking place at A, B, and C, and you should say what change of state, if any. So at A, liquid is cooling down. At B, a liquid freezes. And at C, the solid is cooling down. And suggest why the graph is steeper at C than A. Like why it is steeper at C as compared to that A. It shows because the specific heat capacity for a liquid, they have a lower, like higher specific heat capacity, like they can store more energy, so the temperature change is smaller. That's why when a liquid is cooling down, liquid is losing energy, the temperature change is relatively slower rate as compared to that of solid. Why it is having a faster rate of a cooling? Because the specific heat capacity of solid, as the particles are closer to each other, cannot absorb too much heat energy. So the specific heat capacity of a solid is low. Where liquid, when it is losing energy, slowly it will lose the energy, temperature decreases at a smaller rate. Why? Because the specific heat capacity of the liquid is high. So high specific heat capacity, smaller change in temperature, lower specific heat capacity, greater or a faster rate in change in temperature. So these are the questions we did from one more question we'll solve, and then remaining we'll do next session. Figure 6.1 shows an apparatus that is used to demonstrate some effect of transfer of energy by radiation. So we have electrical heater, a glass bulb which is painted matte black, and a glass bulb which is shiny. The glass bulbs are painted matte black and shiny. The heater glows red hot and switch on. State two types of radiation that are emitted from the heater. Because we can see the light is coming out, so visible light energy is there. And what else? That another one is the heat radiation or infrared radiations. So when we switch on the heater, it is producing a light energy and it is producing a heat energy as well. Before the heater is switched on, the liquid level in the glass bulb are same. State and explain any change in the liquid level. So what will happen to a liquid level? Because dull and dark surfaces are good absorbers, so it will absorb greater amount of energy. Air will expand. As a result, air will expand. It will push this downward. So the level of the liquid will decrease where it is connected to a dull and dark surface. Because air will expand more as it is absorbing greater amount of energy. And as a result, what will happen? The shiny surfaces are good reflectors, so most of the heat will bounce back. A small amount or small quantity of heat is absorbed. So temperature of air will not change too much, or it will not expand too much. That's why the level of the pressure will be low from this side and pressure is higher from the other. So the liquid level will change. So you'll mention dull dark surfaces are good absorbers than shiny. Air expand more in the dull and dark surfaces, so push the liquid downward. So these are the questions from March 17 session. Question 1 to 6. Next session will complete this paper.